Hi, welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I'm going to teach you some algebra right now. This is lesson 8.4 on graphing quadratics, and more specifically, the horizontal translation of these things. So like we said before, we've done a lot of these transformations, but now we'll talk about horizontal translation. Okay, so let's get started. First, let's talk about the idea of even and odd functions. Let's look at these definitions. A function is even when f of negative x equals f of x. Okay? So if the inputs are opposite, we get the same y value. So look at this graph right here. So you can see opposite inputs, like over here. That's the negative of this one, but the y values are the same, or maybe in here. These are opposite, but the y values are the same. Okay, so that's the idea of an even function. And an odd function, right here, f of negative x equals the opposite of f of x. Okay, so it's a little bit different than the first one. And on these graphs, we have we're symmetric around the origin, which is 0.00. So in other words, this point here, this kind of vertex, is symmetrical with this one. They kind of fall. If you drew a line through them, they would go through that origin point. Or this point here would be symmetric with this point here. They would go through the origin point. This point here would be symmetric with one that would be up here somewhere, right? So the idea of an odd function is symmetric around the origin. It's kind of like you flip it up and then you flip it over to make it to see the symmetry there. Okay, so let's take a look at some examples here, and we're going to determine whether each of these functions is even, odd, or neither. And I'm going to pause this for one. So what I've done, I brought over from the other screen these kind of definitions here of when we have even or odd. So we're given f of x equals 2x. So what we're going to do here is do this for f of negative x. See, both of these odd or even checks use f of negative x. So we'll say 2 of negative x, and then 2 times negative x would be negative 2x. So in this case, so like I said, in this case, you can see that we end up with the opposite of this. This is 2x, this is negative 2x, which makes this function odd. Over here, g of x, I'm going to use g of negative x. That'll equal negative x squared minus 2. Negative x squared, well, negative times a negative is a positive, so that's still x squared minus 2. And that's the same. Okay, so g of negative x gets to be the same thing as g of x, as x squared minus 2. So since they're the same, this is going to be even. Okay, they're the same. This is going to be even. And we'll try this one over here. H of x equals 2x squared plus x minus 2. So I'll say h of negative x equals 2 times negative x squared minus x, or plus negative x, or minus x, minus 2. And so negative x squared is still, negative times a negative is a positive, so 2x squared minus x minus 2. Okay, so this does not equal this, but it's not the opposite of it either. If it was the opposite of this, it would be negative 2x squared minus x plus 2, which it's not. So it's not the same as it. It's not the same as the original one, and it's not the opposite of the original one. So in this case, this is neither. Okay. So those are ways that we can check to see whether a function is odd, even, or neither. And let's see what's up next. Okay, so graphing, this is what we're going to be doing today, is modifying that input. And we know that we modify the input, everything is kind of backwards of what we think it's going to be. So when we're subtracting h from x, this is going to be a horizontal translation to the right. Okay? We subtract a number, and if we subtract a negative number, which means we're going to be adding, it's going to go to the left. So that's what all this is over here. When h is greater than 0, so when we're subtracting a number, it's going to move it to the right. That's what this one says. And when we think of this as think of this one here as a times x minus a negative number. Okay, so think of it as adding this number, it's going to go to the left. Okay, so when h is less than 0, negative. Okay, the vertex of the graph is h of 0, so so all we're doing is moving it vertically. We're saying that the y value does not change here. I mean, we're moving it horizontally, so let's check that. We're moving it horizontally, the y value does not change, only the x value. Okay, so let's take a look at this example here. Graph g of x equals 1/2 x minus 4 squared compared to x squared. So we can see that we're going to have some kind of vertical shrink by a factor of 2, or we're shrinking by a factor of 1/2, we should say. And the negative 4 means it's going to be a horizontal translation, not to the left, to the right. So here's our old friend Desmos, graphing calculator. And I'm going to just start with f of x equals x squared. So that's kind of our parent function, just a regular vanilla flavored parabola. And now I'm going to say g of x is equal to, okay, so I'm going to be multiplying by 1/2, which means it should be some kind of vertical shrink, and then x minus 4, and the whole quantity is going to be squared. Okay, so you can see, let's do this here first of all. Let's get rid of the negative 4. Okay, so you can see it's been vertically shrunk, right? It's the opposite of stretch. It's been shrunk. Every y value has been multiplied by 1/2. And then I'm going to change the x values by 4. I'm subtracting 4 from each x value, but that translates it 4 units to the right, which we've seen many times before. All right, let's take a look at our next problem here. Oh, a core concept, the vertex form. So this is very important. Make sure that you understand this here, because this kind of wraps everything into one thing. A times x minus h quantity squared plus k. So A is that multiplier of our output, which means it's going to change the shape of it, or possibly reflect it over the x-axis. This is going to stretch it or shrink it. This h here is going to translate it horizontally. And this k here, adding to the output, is going to translate it vertically. But the important thing here that we want to know is that the h and the k represent the vertex. Okay, the vertex will be at hk right there, and the axis of symmetry is this value for h. The axis of symmetry is x equals h, because we're moving this around, but that's that vertex we're moving around. So hk is the vertex. Very important. Hk is that vertex. Okay, so let's take a look here, and it says graph g of x equals -2 times x plus 2 squared plus 3. Compare the graph to the graph of x squared. Okay, so there's my x squared. So what are we expecting to see here? We should be expecting to see this inverted over the x-axis and a vertical stretch of 2. Now, so that's going to be pretty straightforward. Let me put that in first. Okay, so you can see right here it's been vertically stretched and then reflected over the x-axis. Now let's talk about this vertex because this vertex is going to move. Remember, in the standard form, it's x minus h. So it's minus -2 in this case, so or a plus 2. So this is going to translate 2 units to the left and then 3 units up. Okay. So what are we talking about the vertex here? The vertex is at -2. Remember, it's the opposite of this number. So if it's plus 2, you want the opposite. It's minus -2, then 3. So our vertex is -2, 3. We can see it right here on this graph here. That we're at -2, 3. Okay, here's our vertex. And our line of symmetry, of course, is x equals -2. Consider the function g in the previous example. We want to graph f of x equals g of x plus 5. And the previous graph was g of x equals -2 x plus 2 squared plus 3. So here's the previous graph. So what is this saying here? This is saying that we're going to take this one and we're going to add 5 to the input. So what's going to happen if I'm going to go right in here, I'm going to add 5 to it. It's going to translate it 5 units further to the left. Okay? So see what I did here. This is what this is saying. I'm taking that x, but I'm adding 5 to it. And as a matter of fact, let's do it this way so we can see it even better. X plus 5 parentheses. Okay, so I took that x and I changed it x plus 5, but the real effect here is that it's really x plus 7, which means my line of symmetry is now out here at -7. My vertex is at -7, 3. Okay. That's it for now, and I'll see you in class next time. Thanks a lot and have a great rest of your day.